aldol condensation. So first I'm going to write a point about it and then I'll explain what it is exactly. Okay. So basically, aldehydes, we are studying the chemical properties or chemical reaction of aldehyde and ketone together. Aldehyde and ketones having at least one alpha hydrogen undergo a reaction in the presence of dilute alkali as catalyst to form beta hydroxy aldehyde, which is known as basically aldol, or beta hydroxy ketone, which is known as ketone, respectively. I will explain each one of the point here respectively. This is known as aldol reaction. This is known as aldol reaction. Only aldol reaction. What is aldol condensation reaction? I will write that after the explanation. Please do write it and then let me know.
Done, sir.
So see, first of all, we are going to talk about this alpha hydrogen. What is this alpha hydrogen? So with respect to functional group, as you can see, if I'm going to write this CH3, CH2 and C double bond O, and I'm also going to write this ketone CH3, C double bond O, CH3. You can write CH2, CH3. Now see what happens. This is your main functional group, right? This is your main functional group, yes or no? This is basically your aldehyde, which is the main functional group. Now see, if the carbon which is connected directly to the main functional group, that carbon is known as alpha carbon. And the carbon which is connected to the alpha carbon is known as beta carbon. So first of all, recognize whether this where is alpha carbon and where is beta carbon. Are you getting my point?
Yes, sir.
Now the hydrogen which is connected to the alpha carbon is known as alpha hydrogen. Is that clear?
Yes,
So this is for aldehyde. The carbon which is directly connected to the alpha carbon, directly connected to the main functional group, that is alpha carbon, and the hydrogen which is connected to the alpha carbon is alpha hydrogen. Now see, Ayman, are you there?
Yes, sir.
So I just started, I wrote a point that you will take a screenshot later. See, we are going to recognize with where is alpha hydrogen. So see, this is your main functional group aldehyde, and the carbon which is directly connected to the main functional group is known as alpha carbon. And what is beta carbon? The carbon which is connected to alpha carbon is known as beta carbon. Is that clear, Ayman?
Yes, sir.
Now see, what is alpha hydrogen? So the hydrogen which is connected to alpha carbon is alpha hydrogen. Now see, for ketone, this is the main functional group. So this carbon is directly connected to this carbon. So this carbon is also alpha hydrogen. And this carbon is also directly connected to the main functional group. This carbon is also alpha carbon. And what about this carbon? This carbon is beta carbon, because this carbon is directly connected to alpha carbon. What is alpha hydrogen? So there is alpha hydrogen, 2 alpha hydrogen on the right hand side and 3 alpha hydrogen on the left hand side. Is that clear?
Yes, sir.
So we are studying basically the aldol condensation, in which there must be an at least one alpha hydrogen. If there will be at least one alpha hydrogen, then aldol condensation is possible. If there is no alpha hydrogen, then aldol reaction is not possible. Is that clear, Aman? Now, this reaction occurs in dilute alkali as catalyst to form beta hydroxy aldehyde. If it forms beta hydroxy aldehyde, that is known as ald for aldehyde, ol for alcohol. So it is known as aldol. And if it forms beta hydroxy ketone, so kit for ketone, sorry, this is ketone, not ketone. I just wrongly wrote it. This is ketone. Kit for ketone and hydroxy, that is alcohol. So it is known as ketone, and this reaction is known as aldol condensation. Please do take a screenshot, Ayman. Ayman, are you there? Rim.
Yes, sir.
Are you done with this, right?
Yes, I'm done with this.
Now, I'm going to explain the mechanism of the reaction. I'm going to do it for aldehyde first. You know, this is an aldehyde, and the reaction occurs in dilute NaOH alkali, that is dilute NaOH or dilute KOH. Can you tell me, is this alpha carbon? Yes or no?
Yes, sir.
So can I write this CH3 as CH2? This has 3 alpha hydrogen. Can I write this like this?
Yes, sir.
Now see, always remember that this alpha hydrogen is most acidic. Acidic, that means if it is alpha hydrogen, that means it will release in the form of H plus. H plus, that means carbon will take electron from hydrogen and it will form H plus and it will be eliminated from the compound. So what we will have, CH2 minus, because carbon took electron or gained electron from hydrogen, and the rest part will be as it is. Is that clear?
Yes,
Is that
sir.
clear? Now see, for the aldol condensation, we take 2 moles. So we just use the first moles here, and I am going to take another mole like this, another mole of this, the second mole of this. Are you getting my point?
Yes,
So
sir.
now can you tell me whether this is electrophile or nucleophile? The one which is underlined, electrophile or nucleophile?
Electrophile.
What does electrophile means?
It has electrons.
No. Electrophile, that means phile is lover. Electron lover. Who will love electron? The one which has deficiency of electron? Yes or no?
Yes, sir.
So see what happens here. This is basically acting as nucleophile. Nucleophile is the one which is electron rich species. Electron rich species. because it has negative charge. That means 2 electrons at carbon. That's why it is electron rich species. So the one which you get from eliminating H plus or alpha hydrogen will be nucleophile. Now you took the second mole of ethanol and you are going to make it electrophile. So oxygen will take electron, always oxygen will take electron from carbon. So there will be deficiency of electron here, yes or no?
Yes, sir.
So it will act as electrophile, electron loving, because it will have deficiency of electron. And since this has electron, this is electron rich species, so it will attack on the carbon which will have deficiency of electron. Are you getting my point?
Yes, sir.
Now I am going to write this first. So this is CH3 and this is basically CH, and which is bonded with oxygen O minus. Now this attacked on this carbon, so it will be CH2 and then CH. Now see what I want to say. This carbon donated one of its electrons. Since oxygen took electron from carbon, this carbon, it will have positive charge. But at the same time, this carbon donated electron to this carbon because it has deficiency of electron. So there was positive sign, and then since this carbon donated electron to this, so there will be negative sign. So negative positive cancel each other and they bonded together in this form. Is that clear?
Yes, sir.
Now see, there will be hydrolysis of this. Hydrolysis, that means H plus OH minus. H2 has H2 part, H plus OH minus. This will attack on carbon and it will be basically CH3, CH, OH, and then CH2, and then CH2OH. The CH2, CH. So this reaction is basically, I'm going to explain. As you can see, this is your main functional group. So this is your alpha, wait a minute. This will be your alpha carbon, right? After CHO, the carbon that is present is your alpha carbon and this is your beta carbon. Yes or no?
Yes, sir.
So we can write beta. On beta, there is OH, that is hydroxy, beta hydroxy, and this is your aldehyde. So beta hydroxy aldehyde, or we can say aldol reaction. This is your aldol reaction. Is that clear?
Yes, sir.
So what is aldol condensation? After forming this, you are going to condense it. That means removal of H2. A removal of H2O is gonna take place. So how you are going to remove H2O? From beta carbon, you are going to remove OH, and from alpha carbon, you are going to remove hydrogen. So as you can see, only one alpha carbon is there. So I'm going to write this CH2OH as this CH2H. And I'm going to remove this part, H2. So if I'm going to remove this, there will be double bond between this carbon and this carbon. So it becomes CH3 and then CH and then double bond, then it becomes CH. I wrongly wrote it. It will be 1. And then it is CH. So this is your aldol condensation. That means basically removal of water took place, aldol condensation reaction. And it is also known as you can see, there is double bond, that is ene, and there is alcohol, so it is known as enal. Is that clear?
Yes, sir.
Hyman, why are you not responding? Very good. So what you need to do, just see, there is two type of aldol. One is simple aldol and another is cross aldol. So we are focusing right now on aldol reaction or aldol condensation reaction. So what you need to do, just take first mole and remove H plus alpha hydrogen. If you are going to remove H plus, so the carbon which is connected with alpha hydrogen will get negative charge. And again, you are going to take this mole and C double bond O is there. So it's just oxygen will take electron from one, will have deficiency of and this negative will attack on this, and then just add it and then react with H2O. H plus will go on this, and you will get beta hydroxyaldehyde, which is aldol reaction. Ald for aldehyde, all for alcohol. So beta hydroxyaldehyde, which is known as aldol reaction. If you are going to do aldol condensation reaction, so what you need to do, just remove H2O. And there is a trick. You can remove H from here, but that is not major product. That will not be major product. So always try to remove beta OH from beta. OH will be always on beta carbon, and hydrogen from alpha, and you will get double bond on this. And this is your aldol condensation reaction. So please do write it. I'm going to give you some time to write it. And if you have any doubt, please ask me. Let me know when you are done with this.
Done, sir.
Yes, sir, done.
Done. So I just took an example of aldehyde, which is ethanol. I'm going to give you for propanol. Propanol. You know the formula of propanol, right? Rim and diamond. Both of you know the formula of this, right? Please do let me know if you have doubt. Aman, do you know what is the formula of propanol?
CH3, CH2, CHO.
Very good. Aman, why are you not responding? Is there any problem in your mic or you are not able to understand? Please do let me know. Rim, will you be able to attend this class? And Aman, if I'm going to take an extra class on Friday at 8 p.m. IST. Please do respond.
Yes, sir. I don't think I'll be able to do that class on Friday.
Okay, no problem. And try to take some extra classes in order to cover the syllabus in till mid-Jan. Okay. Will you
Okay,
be
sir.
able to solve it or I should explain it?
Sir, can you explain it, please? I remember, sir, we have to get rid of H2O with.
See, first of all, this is the alpha carbon. You need to search for alpha hydrogen. So this is the alpha carbon and this is your alpha hydrogen, right? And this reaction will be occurring in dilute NaOH or KOH. Dilute KOH. I'm going to take dilute KOH. So what will happen? This electron will be gained by carbon. Hydrogens, alpha hydrogens electron gained by carbon. So it will be CH3 and then CH negative and then CH. And again, you can see we are going to take another or second mole of this CH2 and this will be C double bond O and then H. So what will happen here? Oxygen will take electron from carbon. So this carbon will have deficiency of electron. So this carbon will attack on this because this carbon is electron rich. So it will attack on that. Are you getting my point?
Yes, sir.
Now see, I'm going to write this first, this part first. So it will be CH3 as it is, then CH2 as it is, and then CH. I'm going to write this C and H together, and this will be O minus. Got it? After this CH directly attacked on this carbon, so it will be CH, yes or no? And after this CH, there was CHO, so I'm going to write it CHO. And on the left hand side of this CH negative, there is CH3, so I'm going to write it CH. Got it?
No, sir. So how did you get the CH3?
You can see now this CH has two parts. This CH has two
Okay,
parts.
okay, yes.
This CHO, so I wrote it CHO here, and there was CH3. So
So
either
what,
you can write on
then what
top or
happened to
bottom.
double bond, sir?
Where is the double bond? Yeah, this C double bond O.
Yes, sir.
So oxygen is more electronegative. So oxygen took electron from carbon. That's why on oxygen there was negative. There is negative charge. On carbon there should be positive charge, but at this time this carbon at the same time attacked on this. That means this carbon gave electron to this carbon. So there was positive charge, and since it took electron or gains electron from this carbon, there was positive charge. So negative positive cancel each other. Are you getting my point?
Okay, sir.
Clearly, have you got it, or should I explain it again?
No, sir, I think I got it.
Okay, now you are going to do the H2O, that means H plus or OH minus. So what will happen? This attack directly here, positive positive will go to negative. This is CH3 as it is, this is CH2 as it is, this is CH, and on this there was OH, and this will be as it is CH3, and this is CHO. Now as you can see, this is your main functional group. This is alpha carbon, this is beta carbon, and in beta carbon there is hydroxide. So hydroxy, so we can write beta hydroxy, and there is aldehyde, so it will be beta hydroxy aldehyde, which is also known as aldol. Ald for aldehyde, all for alcohol, aldol reaction. Now we are going to do the aldol condensation. First write it up to this.
Okay, sir. Yes, sir, done.
Very good. Now you can see that to do aldol condensation, you are going to remove H2O. That means H from alpha and OH from beta. As you can see, this is beta, so OH will be removed from here, and alpha is here, so this hydrogen will be removed. So there will be double bond between carbon and carbon. So the rest part will be as it is CH2, and then this becomes CH, this becomes double bond. Hydrogen is also removed with OH in the form of H2O. And there is CH3 and this is CHO. So this is basically your aldol condensation. Is that clear? And it is also known as EN because double bond. What you need to do, just take first mole of either ketone and aldehyde. Just remove alpha hydrogen. Then there will be negative charge on the carbon connected to alpha hydrogen. Then go for again the second mole and remove the electron, or you can say C double bond O. O will be negative. Just break one of the bond
Sir,
and attack this negative. Yes.
which is the first mole?
This is the first mole. We take 2 moles for aldol. This is the first mole. This is the second mole. You can see both are same now.
Yes, okay.
In the first, you can also see I was telling you first mole, second mole. This is the first mole, and in the first mole, what you need to do? Remove H plus alpha hydrogen, so it will have negative charge. Electron rich species it becomes. Now what you need to do? C double bond O. Just make it electrophile. Oxygen will take electron from this carbon. Now this carbon will have deficiency of electrons, so this will attack on this and they will add with each other, and then H plus will go to this and then remove H2, H from alpha hydrogen, OH from beta, and you will get your aldol condensation. It's very easy. Again, I'm going to explain. Alpha carbon, just recognize whether alpha, where is alpha hydrogen, remove at H, then there will be negative charge from where you remove hydrogen. Now just open this and remove this one of the break one bond and give oxygen a negative charge. Now there will be deficiency, so this negative charge carbon will attack on this and add both of them, and again H plus OH minus, H plus will go to this and then remove H2O. Are you getting my point?
Yes, sir.
So in the same way, you can go for ketone. What you need to do, recognize whether where is alpha hydrogen. Just remove alpha hydrogen, there will be charge on carbon. And then again take another mole, C double bond O, take the oxygen will take electron from carbon. There will be deficiency of electron on that carbon, on the second mole, in the second mole. And that negative will attack on that and then add it accordingly. It's very easy. Please do let me know when you are done with this. Aman, are you done with this?
Yes, sir.
Very good. Now I'm going to give you a reaction for this is all aldol. I'm going to give you this. This is the first mole of ketone. You are going to react this with dilute and then take another mole on your own. Now this is your dilute NaOH. Can you do this?
Okay, sir, I'll try. Sir, I'm done with the first part, but I can't solve the other after that.
It's very easy. Can you tell me? You can see alpha carbon, both sides, because both are connected to the same carbon main function
Yes.
group. Yes or no?
Yes.
So you can take any one of them. So I'm gonna take CH2H. This is your alpha hydrogen. Total 6 alpha hydrogen is there, but we need only one. So this will be like this. So it will be CH3, C double bond O, CH2 minus. Yes or no? H plus will be eliminated
Yes.
from this. Now I'm going to take another mole of this. Are you up to this?
Yes, sir.
Now
That's
see
right.
what you need to do. Just take this here. Now there will be deficiency of electron here on this carbon.
Yes.
So it will
This
attack on this part.
carbon.
So I'm going to write it. I'm writing it first on the right hand side. CH3 and it will be CO negative. Yes or no?
Yes, sir.
Yes. And I'm going to write this CH3 downward. Can I write this?
Yes.
Now see, this CH2 will attack on this. So it will be CH2. And then there will be C double bond O. There was CH3. So can I write this?
Yes.
And after this, what you are going to do is just H plus OH minus. This H plus will go to this. And what you will get CH3COH. And then there is CH3. And then there is CH2. And then there is C double bond. And then there is CH3. Got it?
Yes, sir.
So this is your, you can see, this is your alpha carbon, this is your beta carbon. So this is your beta hydroxy alcohol OH hydroxy ketone, because ketone is present, not aldehyde. Are you getting my point? This is known as ket for ketone, all for alcohol. Ketone reaction. Got it?
Yes, sir.
After this,
Do we only have to take out one alpha hydrogen?
H2O, that means OH from here and hydrogen from here. So double bond will come between this and this carbon. So this will be CH3 and this will be CH3 and OH is eliminated. So double bond and one of the hydrogen is eliminated. So one hydrogen is left and the rest part is added. Got it?
Sir, in the first step, do we only have to take out one alpha hydrogen?
Yes. You need to take one alpha hydrogen. Got it?
Yes, understood.
So this is basically ketone. Now we did ketone as well as aldol reaction. Now we are going for cross aldol. Have you written it?
No, sir, I need to copy the last part.
Okay, please do it and let me know.
Yes, sir, done.
Very good. Now going for cross aldol. In cross aldol, there are four products. There will be four products. Cross aldol reaction. So see, cross aldol, that means different aldehydes. I'm gonna take CH3, CHO, ethanol, and then propanol. CH3, CH2, CHO. In the presence of, we are going to do this in the presence of dilute alkali. Either you can take NaOH or KOH. Is that clear?
Yes, sir.
So how will be their four products? It's very easy. We are going to take 2 moles of this and there will be one product, as we discussed in the first aldol. We are going to take 2 mole of this and there will be one aldol reaction, and we are going to take 2 mole of this and there will be one product. As you can see in the first reaction, where it is, yes, here it is. In the first reaction, you can see with ethanol we got a product, this one, aldol condensation. Yes or no? This is aldol. Are you getting my point? Ayman, are you there?
Yes, sir. I said I didn't understand.
It's very easy. When there will be aldol, cross aldol, that means different aldehydes will be there. Different aldehydes will be there. One is, let's say, one is ethanol, another is propanol. These are different aldehydes. Yes or no?
Yes.
So you are going to take this separately, CH3, CHO. So can I write this CH3 as this? Just do aldol condensation or aldol reaction separately for this. So it will go like this, and it is in the in dilute NaOH. Just do it separately, and it will be CH2 minus and CHO. And then again take another mole of this. This will be CH3, C double bond O H. Now what you need to do, remove this to this, and it will attack on this. So what will be the product? I'm going to write this part first. This will be CH3 and there will be O negative. I'm going to write it together, CH, and this attacked on that. So this will be CH2 and this is CH. And then after this, you are going to add H2, H plus, OH minus. This H plus will directly go to this part and it will be CH3, CH, OH, and then this is your CH2, CH. So this is your aldol, yes or no? Are you getting my point?
Yes, sir. Okay.
You are going to do aldol for this one separately as well as this one separately. If you are going to do aldol for this one separately, you will get one product. You are going to do this one for separately, you will get another product. Two products you have made, yes or no?
Yes, sir.
So please do write it. First of all, you are going to do it as you can see I have written, and then you are going to do it on your own for this part.
Okay,
Because
sir.
I already explained it. You have written it. Just don't cheat it. Also write the condensation part here.
Okay, sir.
Please do let me know when you are done with this.
Yes, sir. I'm done with.
You are also done with the propanol?
Yes, sir. You already did it, right?
Yeah, we did it. So what is after aldol condensation? It will be CH3, CH double bond, CH, CHO, right? Because you are going to remove this OH and one of the hydrogen from here, right? And in the same way, you can go for propanol. Propanol. That is basically CH3, CH2, CHO. So in the presence of dilute alkali, what you need to do, just remove one hydrogen, alpha hydrogen. There must be alpha hydrogen for this reaction to occur. So there will be CHO and again CH3, CH2, CH, C double bond O. What we are doing actually, we are making nucleophile. One is nucleophile, another is electrophile. So it will attack on this part. So it will be, I'm going to write this part first, CH3, CH2, and then CO negative, and then H is there, and then CH I'm going to write here, and then CHO was on the right hand side, on the left hand side CH3, so I'm going to write it on the board. So H plus OH minus. So you can see OH will be there, so it will be CH3, CH2, and then CH. There will be OH and then CH3 is here and one hydrogen is there, so I'm going to write it like this, and CH. And what you need to do, just remove hydrogen from alpha and OH from beta, and you will get aldol condensation as this second product. As you can see, the second product is like this, CH2, so CH2 and then CH double bond C and CH3 on the bottom. I'm going to write it on top, and then this. This is the second product, and this was the first product, right? Yes or no?
Yes, sir.
Now for the third product, it's very easy. Now see how third product. I'm going to take this ethanol first and make it nucleophile. Ethanol as this in the presence of dilute alkali. That means dilute NaOH. It's very easy. Now you can see this. Oh, sorry. Now you can see this. There will be CH2 negative and then CHO is there. Now I am going to take another mole, or not of this because it will be repeated. Propanol, and I'm going to make propanol as electrophile. So how you are going to make it electrophile? As you can see, this will be removed here, and what will happen? This will be as it is. So it will be CH3, CH2, and there will be CH, and this is O negative. O negative, and since electrophile, this will have deficiency of electrons, so it will attack on this part. Okay, so this will be attacking here there, so it will be CH2 and CHO. And after this, you are going to do H plus OH minus. So this H plus will be going here. So what you will get? You will get CH3, CH2, and then CHOH, and then CH2, CHO. The third product. If you want to do condensation, according to the question, you are going to write you are going to eliminate water. From where? This is your alpha carbon, this is your beta carbon. So alpha hydrogen, one of the hydrogen from here, and OH from here. So what you will get after this part, CH3, CH2, it will be CH double bond CH and then CH. Got it? This is the third product. How you are going to make it the third product? Just take one of them as make it nucleophile and another electrophile. And for the fourth opposite, you are going to make it nucleophile and this is electrophile. So first write it and then I will explain. Let me know when you are done with this. Please do let me know when you are done with this.
Yes, sir. But I don't understand, sir, this last part.
This last part, which part? Are you able to understand till this part or this part?
So the blue part.
This part? Are you
After.
talking about?
After that.
Are you talking about this part?
No, sir. The next step after the blue part.
Okay, this part.
Yes, sir.
So see, it's very simple. You made it nucleophile and this as electrophile. So this will have deficiency of electron. So it will attack on this. Are you getting my point? Yes or no?
Yes.
Now see, I'm going to write this first. So CH3. After this CH2 is there, and then CH. So CH is there. On C there is O minus. Yes or no? Up to this part clear? Simon.
So can you repeat? I didn't hear it.
See, this part I'm going to write it first. CH3, CH2, CHO minus. So CH3, CH2, CHO minus. Is that clear?
Yes, sir, that's clear.
And since this attacks on this, so this CH2 will be directly attached to this CH. So CH after CH, this is CH2. And after CH2, there was CHO. So it is CHO. Are you getting my point?
Yes, sir.
And after this H2, H plus OH minus H plus will go to O minus. Nothing will change. So it becomes beta hydroxy aldehyde. Yes or no?
Yes, sir.
And after this condensation took place, that means H2O, H from alpha and OH from beta. So this H, you can see there will be double bond between this and this. Rest part is as it is. OH and H is removed and CH. Got it?
Okay, sir. Yes.
So I think it's very easy, right? Now see, this is the third product. In the previous one, you prepared ethanol as nucleophile. Now I am going to prepare propanol as nucleophile. This is your CHO. And in the presence of dilute NaOH, as you can see, there will be like this. So it becomes CH3, CH negative, and there will be CHO. And another more, you are going to take CH3, CHO like this. And you know that this will be like this. So there will be deficiency of electron on this carbon. So I'm going to attack from this. So I'm going to write this part first. See carefully. Focus. CH3, CH and O negative. And you can see that this is basically attacking on that. So this CH will be directly attached. And after CH, there was CHO on the right. And there is on the left CH3. So I'm going to write this on bottom. Got it?
Yes,
Until this. And after this, you are going to do the hydrolysis H plus OH minus. So you know H plus will go to this part. So what you will get, the rest part will be as it is. You just need to add H2O and it will be CH and then CHO, and this CH has CH3. And if you want to do condensation, so just remove H2 from where? From alpha to hydrogen from alpha and beta from beta OH. So there will be double bond from this and this between alpha and beta. So the rest part will be as it is. There is CH, OH is removed, and double bond H is removed. So it left H, C, and CH3 was there, CH was here. So this is the fourth product. What you need to do, just take 2 moles of ethanol and make a product, prepare form of product, produce a product. Take 2 mole of propanol, prepare a product. Second product. Now for the third product, make ethanol first nucleophile and propanol electrophile. Then you will get a product. Then for the fourth, make propanol as nucleophile and ethanol as electrophile. Then you will get the next product. Got it?
yes, sir.
Please do write it. Please do let me know when you are done with this.
Yes, sir. Done.
Very good. So I think it's very easy, right? You can do this.
Yes, sir. I'm
Please do
slowly
repeat
getting.
it. Yeah, very good. Now we are going for other reactions. Aldol condensation or aldol reaction only occur if there is alpha hydrogen. So the next reaction is first is Cannizzaro reaction, and it's very easy. Cannizzaro reaction. So what is Cannizzaro reaction? I'm going to write aldehyde which do not have an alpha hydrogen, do not have an alpha hydrogen. So the aldehyde which do not have any alpha hydrogen, and we can do Cannizzaro reaction from there. Undergo, it's very easy. Undergo self oxidation and reduction, and this reaction is known as disproportionation reaction. You have studied it in class 11. The redox reaction in which an element get oxidized and reduced simultaneously, that is known as disproportionation reaction. On heating with write with me, concentrated alkali. In this reaction, reaction stands for reaction. One molecule of aldehyde is reduced to alcohol, while another is oxidized to carboxylic acid salt. Carboxylic acid salt. Please do it. Then I will explain the reaction. And then we will move on. Let me know when you're done with this.
Yes, I'm done.
Very good. Now see, it's very easy. First of all, you need to check whether an alpha hydrogen is there or not. So if I'm going to ask, can you tell me whether an alpha hydrogen is present or not? You are going to take 2 mole of the same. Can you tell me whether an alpha hydrogen is present or not? concentrated KOH, and you are going to. Can you tell me whether alpha hydrogen is present in this or not?
Yes, sir, it's present.
No. See, this is your main functional group.
Yes.
Is there any carbon that is connected to this carbon?
No.
So there is
But the
no alpha
hydrogen is-
carbon that if there is no alpha carbon, that means no alpha hydrogen is present there. Are you getting my point?
Okay, sir. Only
No.
with the
Yeah,
carbon. Sir.
then directly. Now see what will happen. One of the aldehyde will be reduced to alcohol. That means it will be like this, H and H. So I just reduced one of the aldehydes, so it will become H, H, 3CH, CH3 and OH. And one of the aldehyde will be oxidized into carboxylic acid. Since it is an aldehyde, so you are going to make it carboxylic acid. So how you are going to make it carboxylic acid of one carbon? It will be this methanol will be converted into methanoic acid. Yes or no?
Yes.
But you are not going to make it carboxylic acid. You are going to make it carboxylic acid salt. So whatever is the metal here, potassium, sodium, you are going to replace this OH with OK. Is that clear?
Okay, sir.
Are you going? Have you got it? What you need to do for Cannizzaro reaction, there should be no alpha hydrogen. There should be no alpha hydrogen. If I'm going to give you like this, if I had given you like this, so it is understood that concentrated KOH. So it is understood that you have to take 2 mole of this. One of this will be converted into alcohol, so it will be like this, and another will be oxidized into carboxylic acid salt. That means H will be there and this will be your OK, not OH. Got it? Both are same. So please do write the reaction, and I'm going to give you another question on this. And that is, you're going to take 2 mole of this, then concentrated KOH or NaOH you can take. I'm going to take it NaOH. You can take NaOH or KOH. Can you do this?
No, sir.
Okay, no problem. First, you are going to look for alpha carbon, alpha hydrogen. So you can see first mole, I'm going to take it like this. So this is alpha carbon, yes or no? Because this is the main functional group. So this is the alpha carbon, yes or no? Please tell me.
No, sir.
You are not. This is not alpha carbon.
Yes, sir. That is alpha carbon.
So can you tell me whether this carbon has have alpha hydrogen or not? Does this carbon have any hydrogen? Yes or no?
No, sir.
What you just said?
No.
No. That means there will be Cannizzaro reaction. So for the first, you are going to reduce it, and to reduce it, H add here and add here. So what you will get, the first product will be, it's very easy, man. It will be CH2 now and OH. You can see H is already there, and this hydrogen, it will be CH2 and this is OH. So it is reduced to alcohol. And the second part, you can see second product. This is C double OH. You just need to make it oxidize to carboxylic acid. How you are going to make it carboxylic acid? It's very easy. C double OH, but you don't need to write the carboxylic acid. You need to write the carboxylic acid salt. So H will be replaced by Na. So this is the product. It's very easy. One of the product will be alcohol, another will be carboxylic acid salt. Okay. Is that clear? Is that clear? I mean,
Yes, sir.
can I change the slide?
No, sir. So just 1 minute.
Okay. Can I change the slide?
Yes, sir.
Okay. So the last chemical reaction of this aldehyde and ketones, the second part of this, other reactions are, right with me, electrophilic substitution reaction. On which day you are free? I want to take some extra classes in this month. First, I'm going to write it and then I will explain. Let me know when you are done with this. I'm also going to write the reaction. CHO is basically ring deactivating group. Your benzaldehyde. So if you are going to react this with HNO3 in the presence of H2SO4, you are going to do nitration in cold 273 to 283 Kelvin. It will cover the metaphages. Please do let me know when you are done with this.
Yes, sir.
So see what happens if it is a ring deactivating group and there is a electrophile that is waiting to attack. So as you can see, it will take electron from here and there will be positive charge, so it will be moving like this. So there will be double bond CH and there will be O negative and there will be positive. So this will be moving here. And now you can see that the bond comes here and positive here. And the rest part is as it is. And again, you can see that this is double bond, double bond, double bond. CH, O negative, and there is positive. Again, just move this part to this and this part to this. So you can see, oh, wait a minute, delocalization of pi bond took place, and it is like this. So as you can see, if electrophile, that means electron deficient compound or species wants to attack, it cannot attack here because it already has electron deficient position, as well as it cannot attack here because it already has electron deficient position. And then again, so it can either only attack at meta position. That's why it is meta directing group and ring deactivating group. Got it? If an electrophile file, that means it is electrophile which is the species which is electron deficient molecule. So it cannot, it will attack where electron rich species are present. So here you can see positive charge, that means it is already electron deficient, electron deficient, electron deficient. That's why product at meta forms. Is that clear?